Okay, so we're going to start looking at the history. So before we get into Dalton's atomic theory, I want to introduce you with the first thought. So I want you to think back in the day when we've got kind of like the Greeks, everybody's wearing their toga and they're sitting around just kind of thinking. So this is during the 5th century. And so during the 5th century, a guy named Democritus. So a guy named Democritus, I guess I'm imagining him sitting in his like little toga, maybe under a tree, eating an apple, and they're chatting about philosophy and what is beauty and what is right and what is wrong, and then some guy's like about the planets and all this, and then one guy, Democritus, is like, wonder what everything's made out of. And so he's the first guy to kind of start thinking about what is everything made out of. What is the atom? So the atom is our smallest part. He's like, what is that made out of? Is it the smallest thing? Or is it something smaller than what we've been thinking of? So he's kind of the first guy to kind of talk about it, kind of theorize about it a little bit. But he never really set down a theory. Okay? Also at that time, we didn't have as much technology. So he kind of wrote about it in a more philosophical sense than a scientific sense. So our first scientific idea of what the atom is from Dalton, okay? And this is actually the same Dalton that we showed on the previous slides, okay? This dude, this guy, okay? So he's the first one to kind of write down his thoughts, but a lot of his thoughts he actually got from reading some of Democritus' stuff. So in 1808, remember, you don't have to know the dates, but you need to know who this guy is and what his theory is and the parts of it. I'm giving you the dates so you can just see how fast and how slow some things have changed. So his first thing that he says is that each element is composed of tiny, indestructible particles called atoms. So he's the first one. This is why it's called the atomic theory, because this is where we see the words atoms used. So he's saying that my smallest thing is an atom and it's indestructible. So I can't break it apart. So it's like my Lego block is how you can think about it. Okay? So each element is composed of these small little tiny indestructible atoms. Alright, so then he wants to say that all atoms of a given element have the same mass and other properties that distinguish them from other atoms of other elements. Now you might say, well, this seems to make a lot of sense, Dr. C. Like, why does he write this as his part? Remember, he's the first one to write anything. So if he's the first one to write kind of anything and really put it down, he's got to lay the foundation, the framework. So he's saying that if I'm talking about one element, this element has its atoms, and this element has its atoms. The atoms are going to be different for the two elements based on its mass and then based on several other properties. But mainly he wants to focus on the mass. Okay? Now, the properties under one element, the atoms, under one element are all going to have the same properties, and all the atoms under this element are going to have the same properties, but they're different across elements. Okay, so that's the second one. The third one, atoms combine in simple whole number ratios to form molecules or compounds. Now, this one should sound really familiar. Atoms combine in simple whole number ratios to form molecules or compounds. So Dalton wrote in his atomic theory his law of multiple proportions. He's like, I made this law, and he's going to put that into his atomic theory. Makes sense. Okay. Fourth one. In a chemical reaction, atoms of one element cannot change into atoms of another element. They simply rearrange the way they are attached. Now, this one also might seem a little common sense, but you have to think, back in the day, even around 1800, they thought that you could do some stuff, some like magic or alchemy, and you could take this piece of like lead and all of a sudden it's going to change into gold. Okay? So there was people still at this time that thought that you could just magically make things into gold or diamonds and gems and all this stuff. Okay? And so he's saying in a chemical reaction, atoms of one element, they don't just change into another. So if I put some lead or iron or whatever into my reaction, it's not going to just all of a sudden now change to gold. I don't magically just create a new element. Okay? What happens is that the atoms, they're going to simply rearrange the way they're attached. We're going to talk about this in a reaction, but just think about, instead of it changing from this guy to being this element, he's going to change to who is he attached to. Am I bonded to nobody? Now I'm bonded to somebody. Am I bonded to two guys? Now I'm bonded to two different guys, or whatever. Okay? And we're going to have names for all those different types of attachments and rearrangements. But they're not magically just becoming something new. Okay? All it is kind of like, think about like square dancing. They're all just switching partners. But the person doesn't change when they're dancing. They're just dancing or, being attached to different people. So that's what we're going to talk about when we talk about a chemical reaction. All right, on the next lecture, we're going to talk about how does Dalton's atomic theory change.